It is from 1994 AIPMT. Charge Q2 is at the center of a circular path with radius r. Work done in carrying a charge Q1 once around the equipotential path would be, equipotential path means there is no potential difference. There is no potential difference between any 2 points, but work done depends upon potential difference, charge into potential difference. So in any part you are not doing any work, so total work should be 0. Next, it is from 1995 AIPMT. Two metallic spheres of radii 1 cm and 2 cm are given charges 10 to the power minus 2 coulomb and 5 into 10 to the power minus 2 coulomb respectively. If they are connected by a conducting wire, the final charge on the smaller sphere is, I told you, you can do this problem oral, no need of pen and pencil. We proved that charge will distribute in the ratio of radius. What is the ratio of radius? 1:2. It means from total charge, smaller sphere will get 1 part, bigger sphere will get 2 part. Means if total 3 parts are there, if total 3 parts are there, 1 part will go on smaller sphere, 2 will go on bigger sphere. So what is your total charge? On smaller it was 10 to the power minus 2 coulomb. On bigger it was 5 into 10 to the power minus 2 coulomb. It means total it was 6 into 10 to the power minus 2 coulomb. Divide in 3 parts. If you divide 6 in 3 parts, you will get 2, 2, 2. Give 1 part to smaller, means 2, and 2 parts means 4 to bigger. So smaller sphere will contain 2 into 10 to the power minus 2 coulombs. So we are going with option D. I didn't write any single digit on this sheet. Why? You should know how to calculate oral so that you can save the time. If you are getting this type of lengthy problems, then it means you are spending your time of 2 problems in this. So we have to save time from some another problem. So that's why we solve it orally. Next, it is from 1994 AIPMT. An electric dipole of moment P is placed in the position of stable equilibrium in a uniform electric field of intensity E. It is rotated through an angle theta from the initial position. The potential energy of electric dipole in the final position is, we know that when you put an electric dipole at an angle theta, its potential energy will be, direct derivation they are asking, minus Pe cos theta. At theta angle, potential energy is minus Pe cos theta. So we are going with D, 24th D. Next, it is from 1999 AIPMT. In bringing an electron towards another electron, what will happen to electrostatic potential energy? Concept is very, very simple. You can apply this in each chapter, electricity, heat, magnet, any system. If you are doing work on a system, your energy is spending, and where this energy is going, you spend your energy on system, so it will store in the form of potential energy in system. If system is doing work, it means it is spending its own energy, so its energy will decrease. 2 electrons doesn't want to come closer because they are repelling each other. So you have to spend your energy on system. You are spending energy, means energy of system is increasing. So we will go with B. Next, 26th. It is from 2002 AIPMT. I will dark this minus, and it is not looking like minus sign, so I am darkening it. What is the problem? Identical charges minus q are placed, it is again minus q, they are writing, that's why in bracket, are placed at each corner of cube of side B, cube, not square. Then electrostatic potential energy of charge plus q, which is placed at center of cube, will be. So how many charges are in your system? Each corner of cube of side B, we are putting one charge minus q, and center plus q. First I am making cube so that you can understand the actual figure. This is it is a cube. 8 corners are there. A, B, C, D. Now, E, F, G, H. We put at center a plus q charge. You know that center means middle point of the diagonal, which is equidistant from each charge. We have 8 charges. So we have to calculate potential energy 8 times. For each pair we can calculate. So 8 pair will be formed. Potential energy due to A, potential energy due to D, potential energy due to C, due to B, due to E, due to F, due to G, due to H. But all potential energies are equal. Why? All charges are equidistant. So we will calculate potential energy only for one charge. You can take any one. Magnitude of all charges are minus q, minus q, minus q. At every corner you keep minus q charge. All 8 charges, but at center you put one different charge, that is plus q. It is the center of your cube, and you put plus q charge at this point. So it means total energy should be 8 times energy of one pair. But we have to find distance. You know, the diagonal of cube, the length of diagonal of cube is a root 3, but side is given b, so b root 3. So distance of each charge from center is b root 3 by 2. So potential energy should be 1 upon 4 pi epsilon naught q1, one charge is negative, q2 another is positive, upon r, distance between two charges is center and one charge, b root 3 by 2. Take 2 here. So what we are getting? We are getting means minus sign. It means the option cannot be correct. The option cannot be correct. Energy should be negative. 8 into 2 and this is 4. You can cancel 4 with 8. You will get 2. So what is in numerator? 4q square should be in numerator. In a denominator, we are getting pi epsilon naught b and root 3. It means we should go with option C. So C option was correct. Next, it is from 2003 AIPMT. What is the problem? An electric dipole has the magnitude of its charge as q and its dipole moment is p. It is placed in a uniform electric field E. If its dipole moment is along the direction of the field, the force on it and its potential energy are respectively. We know that if you put at theta angle, potential energy, see how to attempt a problem in competitive exam. You are getting potential energy in 4 options, in 3 it is different. So we will go with potential energy, maybe only with the help of one thing you will get your answer. Potential energy, what is the formula? I told you minus PE cos theta, but it is aligned in the direction of electric field. So theta is 0 and cos 0 is minus 1, cos 0 is plus 1. So what we are getting? Minus PE. It is the maximum value of potential energy, a minimum value of potential energy, because cos theta cannot be greater than plus 1 since it is minus. So when cos theta will be greatest, it will be minimum, minus will make it less. So what should we do? P means Q into E. An electric dipole has the magnitude of its charge is Q. So 2 and its dipole moment is P. So no role of Q because length is not given. If its dipole moment is along the direction of the P field, the force on it and its potential energy are, see, when dipole is along the electric field, net force should be 0 because one force QE is in this direction, on negative charge it is in this direction. That's why it stops in this position, and 0 is given only in C. So it should be 0, force should be 0, and potential energy is minimum. It is also given minimum. So we are going with option C. Next, it is from 2005 AIPMT. What they are asking? Two charges Q1 and Q2 are placed 30 centimeter apart. Figure is there. A third charge Q3 is moved along the arc of a circle of radius 40 centimeter from C to D. The change in the potential energy of system is this. What should be Q? What they are saying? Two charges Q1 and Q2 were placed at this point. And initially Q3 was at C. What was its potential energy? When Q3 approached to D, potential energy of Q3 is changed. They are saying that change in potential energy is this. what should we write in place of K? So first we have to calculate what is the potential energy of Q3. They are saying the change in the potential energy of the system is, in our system we have this pair of charges, one, this Q2, Q3, two charges. Now we have only two charges. Q1 is at A, Q2 is placed 30 centimeter B. So first we will calculate initial potential energy. What we will calculate? Initial potential energy. What is initial potential energy of Q3? Due to this charge Q1, it should be 1 upon 4 pi epsilon naught. Due to Q1 and Q2, since position of Q3 is only changed, Q1 is Q2 as same. So if we will consider that Q1, Q2, it will be cancelled out. We are going to take difference. So we will calculate only potential energy of two system of charges, Q1, Q3 and Q2, Q3. We will not add Q1, Q2 because it will be cancelled out. In both cases it is same and we want to take difference. So Q1, Q3 and Q2, Q3, what is total? 1 upon 4 pi epsilon naught Q1, Q3 upon distance. What is distance? It is 40 centimeter, means 0.4 meter. Due to Q2, 1 upon 4 pi epsilon naught Q2, Q3. Distance, Pythagoras you can use. If one is 30, another distance is, one distance is 30 and second distance is 40, so it should be 50. Distance 50 centimeter means 50 upon 100 meter, 0.5 meter. It was initial potential energy due to these two system of charges. And next you can write, if you want to write, you can write, but it will be cancelled out. System's potential energy 1 upon 4 pi epsilon naught Q1, Q2 upon 0.3. What is final potential energy when you move that Q3 charge? Now Q3 charge is at D. It is an arc of radius 40 centimeter. So 1 upon 4 pi epsilon naught. Distance is same from Q1. Q1, Q3 divided by 0.4. But it is nearer to Q2. So 1 upon 4 pi epsilon naught. Q2, Q3. Now distance from this is only 10 centimeter. This should be 10 centimeter. So 10 upon 100 means 0.1. And 1 upon 4 pi epsilon naught. That system of charges Q1, Q2 by 0.3. We want difference. We want difference UF minus UI. What I was suggesting, if you are not writing this, no use, it will be cancelled out. It is also cancelled out. So we are taking 1 upon 4 pi epsilon naught common and Q2, Q3 again common. So what we are getting? 1 upon 0.1 minus 1 upon 0.5. It means Q2, Q3 upon 4 pi epsilon naught. 0.5 minus 0.1, it should be 0.4 upon 0.1 into 0.5. multiply numerator and denominator by 100, Q2 Q3 by 4 pi epsilon naught. You will get 40 in numerator and 5 in denominator. So we are getting 8. Q3 is written there. 4 pi epsilon naught is written there. So what should be remaining? It should be 8 and Q2. So we are going with option A. So in this way we got 28th option A. Next problem is from 1996 AIPMT. A point charge plus Q is placed at the center of a cube of side L. The electric flux emerging from the cube is, if Q charge is inside the cube, direct problem from Gauss theorem, total flux should be that surface Q upon epsilon naught. So we are going with A. So we got A option correct. Next, it is from 1998 AIPMT. What they are saying, a hollow insulated conducting sphere is given a positive charge of 10 microcoulomb. What will be the electric field at the center of the sphere if the radius is 2 meters? We discussed 3-4 times solving the problem and discussing the theory. In hollow conducting sphere, inside there is no electric field. So answer should be 0. So we are going with C. Getting my point? We are going with C.